All right, section 5.2. We are going to do kind of the same thing that we did on section 5.1. We're going to still use this triangle, and we might as well use the same looking triangle just to be consistent. This doesn't have to be, this doesn't just work with a triangle that looks like this. I mean, I could have used an obtuse triangle. I could have used a right triangle. I don't know. I just happen to use a triangle that looks like this. I don't know, just to be consistent, I guess. All right, so what we're going to do today is we are going to learn a word first, and then we're going to learn what we're going to do with this triangle. So I tell you what, tell you the truth, let's get rid of that triangle for right now. Let's learn the word. Now, you know what? I'll stick the triangle there. Got to keep straight what I'm going to do. Let's write down the word. The word is this. It's called median. Has anybody heard of median? Remember when you were like in, I don't know, was it elementary? Maybe middle school, like early middle school, 6th, 7th grade maybe. You learned 3 words. All started with an M. Do you remember that? What was that? Yeah, remember that? Mean, median, and mode. What was the median? Do you remember what the median? It's the middle number, right? It's not the average, is it? It's the middle number. So if I had a whole bunch of numbers, I put them in chronological order, and the one that's in the middle is the median. Also, like if you're going down the highway, right? Going down 95, there's a big old grassy area in the middle of the 2 highways, right? One's going north, one's going south. What do we call that big old grassy area in the middle of the roads? The median, right? I had a guy who I knew, and we were out playing football or something, and I don't know, the ball went out, and it went into the median. He's like, oh, he says, the ball's in the medial strip. He said the medial, and he just didn't know the word, and medial isn't even a word anyway for anything. I just thought that was funny. I don't think so. Medial? I don't know. But I just thought that was kind of funny. I didn't say anything to him because he was an older guy. He was a man and I was a kid, you know, so I wasn't going to say anything to him. But I always remember that to this day. He always called it the medial strip, just because you hear things, but you don't hear it correctly, right? You don't read it, you don't look into it, and you just hear it. And he probably heard somebody he thought they said median, but he might have heard it as medial. I just thought that was funny. But anyway, he was an older gentleman. He's probably about 70 right now, but he was probably in his 50s back then. All right, so anyway, it's median. It's not medial. It's median. Another word he said was, we were playing football. He said, oh, he's out of balance. He's out of balance, but he didn't say out of balance. He didn't mean out of balance. What do you think he meant? Out of bounds, right? Bounds for boundary, right? But he said out of balance. So that's 2 things I remember. Isn't that terrible? Even as a kid, that's what I remember. But he's a great guy, but that's what I remember. Anyway, median. Let's talk about median. It's probably true. He might have had a problem with hearing because he probably didn't hear things correctly, or he just didn't research it enough to know what the word actually says. I don't know. Sometimes I'm a little weird about that. If I hear a word and I don't know it, I'll look it up. Nowadays, it's easy to look it up. But even as a kid, guess this is how dorky I was. Because my dad used to tell me to do this. Hannah, you laughed at me. You're probably thinking, dorky then. You're still dorky now. Is that what you were thinking? Is that why you laughed? No. So my dad would say, like if I'd ask him what a word meant or something, he said, look it up. Look it up. And my dad probably knew it because my dad's a pretty educated guy. And but he always made me look it up. So what would I do? That was back before the internet, way before the internet. So I'd go to the dictionary. That's right. Anybody ever do that? All right. Their parents. Does anybody have their parents ever tell you that to look it up? Right. Right. Yeah, but he's doing you a favor. You should be thanking him, because my dad did me a favor by making me look it up. Because I learned a lot of things by looking words up. Okay, and I think that's a good thing. In my other class, we said a word. I don't think it was this class. I think it was the other class. What was the word? Oh, I gotta look it up now, because I forget it. I forget what the word is. I know it was a brand new word what I learned yesterday. Shoot. I bet you somebody in that class don't remember it. All right, let's stick with this. I should start this thing over again, shouldn't I? That's okay. What is the median? Well, the median does this. It's a line segment, all right, that starts at a vertex. All right, it doesn't start at the midpoint or anything like that. It starts at a vertex, and it goes, where do you think it goes to the opposite side? Think of what that word median means. Okay, down the middle. Where down the middle? Do we bisect this angle? Nah, because we did that yesterday, didn't we? We bisected, or the last 2 days, really. We bisected this angle, and that was the angle bisector. But we're not doing the angle bisector this time. We're doing the median. So where do you think we're going to hit it? Down the middle. I don't know if I like that term. What do you say? We're going to hit it where? Perpendicular? Does perpendicular mean median? What is median? To the middle. So give me a good geometry word. The midpoint. The midpoint. That's what I'm trying to get you to say. All right. We don't say middle. We say it's going to hit the what? The midpoint. I'm trying to get you to think geometry vocabulary here. All right. We're going to hit the midpoint. I don't know. Where's the midpoint? About right in there somewhere? All right. We'll guess where it is. Oh, I was pretty close. All right, Dan. Being a little obnoxious now. All right, so that right there, that looks pretty good. So what is that yellow line right there? It is a what? Median. Why is it a median? Because it starts at a vertex and it goes where? To the midpoint of the opposite side. Everybody see that? So I could actually draw 3 of these, couldn't I? Because I got 3 angles, I got 3 vertices, so I could draw 3 midpoints, or 3 medians, sorry. I'll tell you what, let's find the midpoint of this side. So if I go all the way right there, that's probably it about right there, isn't it? That's a midpoint right there. And let's find the midpoint of this one. Did I do that right? Yeah, that's probably right. It's still about right there, isn't it? Okay, so those are our midpoints. And let's go to yellow again. And let's start at this vertex right here. So where are we going to go? We're going to go to the what? To the midpoint. Now guess what? Guess what? Just take a wild guess where you think this third one's, what it's going to do. Now we know it's going to go to the midpoint, but guess what? Right. So what is the word when 3 lines hit at the same point? Well, it's neither one of those. But what is it when 3 lines intersect in the same point? We did learn this. Now, it doesn't bisect. What is it? It starts with a C. We say the lines are, what is it? What is it? Concurrent. Right. Concurrent. Right. And we're at the point where they hit, Caitlin, is the point of concurrency. That's what you're saying. All right. So watch. If I go to the midpoint, look at that. It hits right there. 2 days ago we learned it. Look it up. Okay, it's on there. So look what happens. Look, I went, yes, that's right. So I went to the midpoint of each opposite side, and guess where all 3 of those points, they hit each other. So that means the 3 lines are concurrent lines, okay? They're concurrent lines. This point is the point of concurrency. Now that's a very general statement, okay? Any 3 lines, no matter if it's in a triangle or whatever, any time you have 3 or more lines that cross each other at one point, they intersect each other at one point, we call them concurrent lines, and that point is the point of concurrency. But this right here, how did we form this point of concurrency? What did we do? We found the median, right? We found the median of all 3 angles. You follow me? Those are the medians of the triangle. Right, and I kind of warned you though, didn't I? I warned you in the last couple days to keep the stuff that we did yesterday and the day before straight, because we're going to learn a couple more things, right? And it is, that you're absolutely right. The most confusing thing about this is just keeping it straight with the other ones. So you're going to have to review it every once in a while, okay? Review it. In fact, they have a nice little chart that helps you out on page 337. Look there. Look at page 337. And they give you a nice chart, and they kind of put it all together, so you don't have to go thumbing through your notes or thumbing through the book. They put it all in one nice chart. Everybody see it? It's all blue looking. All right. How do you find the circumcenter? Look all the way to the left. What does it say? Find the perpendicular what? Everybody at the chart? Anyway, I got like 3 people with their books open looking where I'm telling you. Look. Circumcenter. How do you find the circumcenter? Look at that chart. What do you do? Draw the, I said 337. It's right there in front of you. I even wrote it down on the screen. Find the perpendicular bisector, right? They even show you how to do a perpendicular bisector. In that first picture, they only do one side just to kind of isolate just one of them. But then they give you a little property about it, and then they tell you what's true about it. They say it's equidistant from all 3 vertices. Okay? Look at the second one, angle bisector. Angle bisector, right? If I do the angle bisector of all 3, what do I find? The incenter, right? And what's true about the incenter? It's equidistant from the 3 sides. So that's what we did the first 2 days. Now today, look down the list. We did the median, didn't we? So guess what this point is called right here? This point of concurrency, that's called the centroid. All right, that point right there is the centroid. And Cookie's absolutely right. The hardest thing about this is just keeping straight which one's which. All right, and that chart can help you out a little bit. All right, but you're gonna have to review it. You're gonna have to go over it every night. You know, okay, circumcenter. How do I find the circumcenter? Okay, I find the perpendicular bisectors. How do I find the incenter? I find the angle bisectors. How do I find the centroid? I find the median of all three angles. Okay, does that make sense? You just have to review it. I haven't thought of any kind of a cool, easy way to remember which one's which. If you come up with something really cool, you know, with the letters stand for something, I don't know. You know, let me know, because I really haven't found a really cool way to know which one's which. It's just a matter of memorizing them, okay? Just learning them and studying and reviewing and going over them. We good? All right, actually, let's not get rid of the centroid word. Let's keep centroid right there. Now, there's something special about this point. Remember, there's something special about the circumcenter, right? It was equidistant from the three vertices. Okay, that's not a circumcenter. So if I went from here to here, here to here, and here to here, they're not all going to be the same. All right? Because that looks a little shorter than that, doesn't it? All right. What if I go, is it equidistant from the sides? No, it's not. Okay, now it looks kind of close, right? But it's not going to be. Here's what's special about this. Let's do this in another color. And I'm just going to put some numbers in here just to kind of show you. This point right here divides this original median. Let's call, yeah, we'll just put some numbers in here. Let's say the length of that is 2, all right? Now watch what happens here. Look at this median right here that it's a part of. We'll call it AB. All right, see AB right there? And we'll call that C in the middle. If this is 2, this line right here, I'm going to tell you what, I think we drew it pretty accurately. Let me just show you. I'm going to copy and paste it, and let's rotate it so it's a little more horizontal. Oh, actually, you know what I should have done? Sorry about that. Forget that. And I'll tell you what, let's stick with this. We got some time. So there's that. I got it. Okay, there's that, and there's that. There we go. Copy, paste. There we go. Because that point right there is important. That's an important part of what I want to show you. Now, what am I trying to figure out here? I'm trying to figure out, is there a relationship between this and this? What do you think? Well, let's do this. Let me put my little pen right here and go to there. Would you agree that's the same length? We're pretty close to it. Yeah. Okay. That's pretty close, isn't it? To the same length right there. Now watch what happens. What if I put it here? Yeah. I don't know if that's really going to be... Let's see if it is. Ah, yeah, it does. Works pretty good, doesn't it? Look at that. Takes 2 of those red ones, right? It takes 2 of these lengths to make this whole thing right here. So Cookie said it. What's true from A to C? What is true about that compared to C to B? Well, AC is double CB. Everybody see that? All right, and that's absolutely right, because we're pretty accurate on this. Using this program is nice because we can have a level of accuracy that I couldn't have had when I drew this on the whiteboard, and that's how I used to teach all the time. So now it's kind of nice, because if this is 2, what do we know about AC? It's 4, isn't it? Because it's double it, right? We marked it all out, right? And I showed you exactly that, you know, this was twice as big as this, so that would be 4. Now that's true about all the other stuff too. A, B, C, we'll call it D, E, F, G. All right? That's true about the other medians as well. Now watch. From the vertex to the centroid is twice as big as it is from the centroid to the other side, to the midpoint. Everybody see that? So from the angle to the centroid is twice as big as it is from the centroid to this midpoint. Got it? Twice as big. So the same thing is true about the other ones. So what if I said that this was 3? What could you tell me? CG is 6, exactly right. Everybody see that? Because this is the shorter side, this is the longer side. The longer side is twice as big as the shorter side. All right, so this is twice as big, so that's got to be 6. Does that make sense? All right. What if I did this? What if I said that that was 10? DC was 10, then CF would be 5, wouldn't it? You with me on that? Okay. Now, watch this. What if I said, let's get rid of all these. I'm just making all this stuff up. I'm not saying it's accurate as far as the measurements and stuff. But what if I told you that DF was 18? That means what? That means that whole thing, the whole entire thing, is 18. Let's think about that. Now remember, this part DC is twice as big as CF, isn't it? Let me ask you this question. What fraction of the whole entire thing is CF? Is CF half of it?
No.
Right, I just want to see if somebody else is. No, you're good. I just want to see if somebody else can. So it's what is it? It's 1/3, isn't it? Okay? Look, so CF is 1/3 of the whole entire thing, isn't it? Or DC would be how much? 2/3 of the whole thing. Would you agree? Now, if you look at the definition or the theorem on here, they say that the distance from here to here is 2/3 of the whole thing. Sometimes I think that's probably the most confusing way to remember it. So the easiest way to remember it is the shorter one is 1/3 of the whole thing, right? Or the shorter one is half of this one right here. Or what? This one is twice as big as this. It's all saying the same kind of thing, isn't it? Exactly. Just take 1/3 of it. That's why I picked 18 to make it come out real nice. So what would you do? You'd take 1/3 of 18, which means you do what? You divide it by 3, right? And that's 6. Yep. So this would be 6, wouldn't it? And then this is double it, which is 12. And 12 and 6 is 18. And this is 1/3, and that's 2/3, isn't it? Okay. Does that make sense to you? Okay, that's pretty easy to see. So if they give you the whole thing, first thing I would do is find the shorter one. Just take 1/3 of it, right? Divide it by 3. And then to find the longer piece of it, not the whole thing, but the longer piece, I would just double the short one. Everybody got that? Okay, sometimes the numbers won't look so pretty. Sometimes they'll say this. They'll say DF is like 10. All right? It's not going to come out quite as nice as when I picked 18. I picked 18 for a reason, so it would come out nice and pretty. But what if DF was 10? What would you do? What would you do first? Would you find DC first, or would you find CF first? CF. Okay, it's a little easier to find CF, I think. So what would you do? You take the 10 and do what to it? Divide it by 3. Well, we'll just keep it 10/3. Just keep it 10/3. All right? You don't need to, if you want to, you could. All right, if you really, really want to, what is this? 3 and what? How about 1/3? We'll keep it as a fraction, okay? 3 and 1/3. Do you agree? 3 times 3 is 9, plus 1 is 10. Yep. So that's 3 and 1/3. But it's a lot easier to find DC with an improper fraction than it is this. Right? Wouldn't you agree it's a lot easier multiplying this by 2 than this by 2? I think so. So how would you multiply that by 2? 10/3. If you double it, what do you get? You just get 20/3, don't you? And what is that? 6. And what? Because 6 times 3 is 18. Take it away from 20, which is 2/3. So it's 6 and 2/3. All right? We hardly ever take a mixed number and multiply it by something, do we? We always change it to an improper, and then we multiply it. So what would this length be right here? 6 and 2/3. Or just keep it 20/3. I'm fine with that. All right? So that would be 20/3, and what would this be right here? So it'd be 10/3. You okay with that? Now you know what they're going to do now, right? They'll probably put some x's in there, right? Don't they always do that? Yeah. They'll put some x's in there. They'll say it's 2x plus 3, and the other one is 3x minus 5, or something like that, right? And then you got to figure out what to do with that. So what would you do? If they told you this is twice as big as this, right? Or this one, this little one, is half as big as this. Or this little one is a third of the whole thing. All right, a lot of things to keep track of, but it all works out to be the same thing. Does that make sense? Okay, good. All right, we got one more to do. But you know how all three of these had something special about it? Yep.
When it has the x, I mean, if you find what CF is and you get the answer equals x, you plug it in and then multiply it by 2.
Well, it all depends on the problem. Yeah, if this has an x in it and this has an x in it, yeah, you would solve for x, plug it in, find this, and just double it and find this. Is that what you asked? Okay. All right, let's do one more. When do we get out of here? Wednesday, third period, 20, like in 2 seconds. Really, this next one is not that super important because there's nothing special about it. All right, this is called the Orthocenter. Orthocenter. But it's really not that big of a deal because there's really nothing special about it. The only thing special about it is that they're concurrent. And how do we find that? We find the altitude. Watch what we do here. We're starting at the vertex. The altitude is you go perpendicular to the opposite side. So look, if I went perpendicular to this side, and if I went perpendicular, now we did, here, hold up, don't leave yet. Don't leave yet, I got a worksheet for you. Actually, I lied, I don't have a worksheet for you because I was supposed to get it copied in the office. I sent it to them. Why is people leaving? You're going to need to come back and get that worksheet. You're going to need to come back and get that worksheet after this class or after your next class or something like that. Before the end of the day, come back and get the worksheet because it's in the office. I got to get it from them.